Hello, everyone. I'm John Kelbley. I'm on the Azure Advanced Migration team. And with me, I've got Trevor Davis, who's one of our AVS Ninja Masters as far as Azure VMware solutions. And we're going to talk about storage considerations for AVS and also options that you might not have considered in addressing storage challenges as you roll through your AVS deployment. We're going to run through a couple of quick common storage challenges that people run into, primarily capacity. Talk a little bit about data collection and how you might pursue collecting some data and analytics around your workloads that you're going to be moving to AVS. Some options for adjusting vSAN, and then really dive into opportunities for both shrinking VMs before and after you move them to AVS, but also options for adding external storage, including using iSCSI or NFS to storage-bound clusters with AVS.
So Azure VMware Solution is a hyper-converged VMware cluster, and as I'm sure everybody who's watching this is aware, it's based on vSAN. So what is vSAN? vSAN is a pool of local disks that are aggregated and presented to the VMware cluster as a data store. So when you consume Azure VMware Solution, you are given a data store that is equal to the aggregate of the local disks across all the hosts. Each AVS node or host that you consume with your cluster, you get 15.36 terabytes of raw disk. So what the usable capacity is something less than that, and it will depend on the vSAN configurations, which we'll talk about later. But what you should be aware of is whatever your capacity is of your vSAN cluster, you do need to keep 25% of that free, and that's just a function of the way vSAN operates. So what that leads to is that AVS is highly performant, but also highly configurable because it owns the storage, right? vSAN. The bad news is that each host that you get has a very finite amount of capacity. And if you want to grow the amount of storage, you need to add hosts. And if you don't have that equal need for compute, it makes storage of an Azure VMware solution the challenge in bringing that to production.
Because all of the AVS nodes are identical. You can't add another tray of disks to it, another thing. So as long as you want exactly what we've got, you're set.
That's right. So what we see a lot of times with customers is that they may have a ton of storage that they need, which let's say they would need 16 nodes to support that storage, but from a compute perspective, they may only need 7 or 8 nodes, right? So they're paying a premium to get, they're buying 3 things when they only need 1 thing. So they're buying CPU, they're buying memory, and they're buying storage to grow the cluster, when in reality they only need to buy storage.
Because the nodes are typically very storage bound when people initially look at what they're going to be doing with them.
Generally, we run into storage bound architectures or storage bound needs from the customer.
So when you kick off a project, you start by doing a little analytics, right? Trying to figure out what it all looks like.
Yeah, exactly. So it's one thing to understand that you're going to probably get this, or you may get this challenge, but you really need to not go into it with an assumption that you're going to get this challenge, but really do data collection to try to understand how to best size the cluster. And what I mean by that, and we'll talk about this in a little bit, is that there are other periphery solutions we can leverage with Azure VMware Solution because it is an Azure service, and therefore we have low latency, high bandwidth to other Azure services, and we can leverage that to try to offset a lot of our big storage need if we run into that. So to take a step back, the first thing you need to do when you're engaging with a customer is collect data. So what we need to collect is CPU, memory, and storage in use and provisioned of their current environment. And you can do that in a few ways. If the customer knows it, they can provide it to you. But typically, 9 out of every 10 engagements that we're involved in will use one of two tools. We'll get the customer to do an RV Tools assessment, which as it shows here, it's a free VMware tool that the VMware administrators typically are very familiar with. And what that does is it just creates a spreadsheet with tons of information about the customer's cluster. And from that, what we'll do is we'll extract the relevant data points that we need to be able to size the environment. And alternatively,
as I say, Azure Migrate, you're an old VMware salt, right? So you know RV Tools from back in the day from your youth. I'm being a Microsoft employee forever. I would always think, well, we must have something. Why wouldn't we use Azure Migrate?
Yeah, Azure Migrate actually is a really good tool as well, because what you can do with Azure Migrate is you can install an Azure Migrate virtual appliance onto your VMware cluster, and it will collect data regularly and essentially ship it off to Azure Migrate, and then we can use that tool to get a lot more detailed on what is going on in your on-prem environment, and then align that to what you would need from an AVS perspective.
And then in either case, you're going to collect the data, but you're probably going to jam it into Azure Migrate to do the sizing.
Right, exactly. So either way, you're going to leverage Azure Migrate. Either you're going to let Azure Migrate collect it out of the gate, and that's and now you got what you need straight away, or you're going to take that RV Tools output and then you're going to reconfigure it for Azure Migrate and then upload it to Azure Migrate to then get the sizing. And we'll go through that in the next slide here. So what you see here is a CSV download that you're going to pull from Azure Migrate. And there's a lot of columns in this, but if you're going to leverage RV Tools to then populate Azure Migrate spreadsheet, you really only need one thing. You really only need a few things. You're going to take the server name, the amount of cores of that VM, the amount of memory of the VM, the OS name, and then the size of the disk, and input it into that spreadsheet. And what you see below here is what you are going to get from RV Tools. So as you can see, that's just one tab of a multiple tab RV Tools output, and you're going to grab that data from the green columns and convert that to Azure Migrate. But we're not here to really kind of explain all the gory details on how to do that. We can there's documentation out there that shows you how to do that. But the net of this is that you need to get this data. And when you get this data, why is this very, very powerful data in terms of sizing, particularly to storage, is that you'll be able to then dive into the details of each of these virtual machines and try to identify these outliers.
And so you've got a pro tip down here. It says enter provision storage versus in use. When you're saying provision, is that because you may have thin provisioned and you want to know what the capacity of the disk would grow to potentially?
Yeah, that, but also really there's a lot of times where maybe the virtual machine has a terabyte drive assigned to it, but they're only consuming a couple hundred gigs. So if there's environments where there's a lot of oversized disk, versus consumed disk, then there's an opportunity there potentially to resize these virtual machines as you bring them over.
Right, because somebody may have over provisioned when they originally, and I always like VMware people like you, Trevor. You always thick provision stuff. It seems a lot of times.
Yeah.
And if you got into that habit with VMware 5.5 and moved up, and then now you're going to go to Azure, you're going to have spare capacity probably on some of these hosts, which you could.
Yeah. What we generally see is that disks are very much over provisioned. And when you do the calculation of, okay, I got 50 terabytes of disk, in reality, when you look at it, you may only have 20 terabytes of actually consumed disk.
Gotcha. And the whole goal of this exercise is really to find some big servers that maybe you can do some triage on to get those whales shrunk down, and then maybe even move those workloads off of AVS to make the nodes more consistent from a storage utilization perspective.
Yeah. So what I'll do is when I'm engaging with a customer is that, we have all this data, right? And okay, we got the list of the 500 or the 1,000 virtual machines or whatever. What we'll do then is generally there'll be this rough order of magnitude sizing, right. And then we'll dive into more of the details of, okay, well, what's actually driving this sizing? And then if we start to look at the actual virtual machines that have been assessed, I can almost guarantee you, one, there's going to be virtual machines that have been assessed that are not moving. Example, backup hosts, right? There'll be backup hosts in there that are consuming, terabytes of data, potentially, that are not moving, so you can just delete those off the list. Then you start to look at these other high storage consumption workloads, and what we typically find is there's file servers and databases. And if you kind of take the file servers, the backup hosts, and the databases, they're a huge percentage generally of what is being migrated to AVS. So what's our opportunity here? Let's try to not have to grow the cluster to support all the data that's being consumed or being leveraged by the databases and the file server.
Right, because like file servers, probably 80-90% of that data is never going to be accessed again by an end user. So why don't we get it off of there? And we can do that transparently. And we'll show you a couple of strategies to deal with that.
Yep, exactly.
As you run through.
Right. So one of the key things, so just to kind of dive into how to do the assessments of Azure Migrate, or any assessment, quite honestly, right, whatever tool you're using. When you use Azure Migrate to do the sizing, there's a few knobs you're going to have to pay attention to that are going to impact your the sizing output. So the vCPU to physical CPU over subscription is configurable in Azure Migrate. You're going to want to configure that, and ideally you're getting that data from the customer and what they're comfortable with or what they're seeing on-prem. And if they don't have it, I would go with 4:1 as your default configuration. Also, what dedupe and compression ratio do you expect to get? If the customer is leveraging storage on-prem that they're leveraging dedupe and compression, get that piece of data from them, put it in here. If they don't have it, I would go with 1.3, 1.4 as an assumption, and then also configure the failure to tolerate and RAID level, which you would expect to use, and we'll talk about that in a couple of slides. Getting more into the details of how to optimize your storage consumption on vSAN, because there's the aspect of, well, what can I run in peripheral solutions or adjacent solutions to AVS? But then the vast majority of your workloads you are going to run, or the storage is going to sit on your AVS private cloud, and so you want to make sure that you have vSAN dialed in to optimally consume or not consume space, right?
So in what you said, like if I do a 3-node cluster, I've got about 15 terabytes per node of raw capacity, which means I've got a total of 45. I got to keep 25% out for vSAN. That leaves me about 40. And if I've got a 3-node cluster, I've got a mirror. So I
Yep.
really only have about 20 terabytes of usable capacity on my vSAN recluster
That's
node.
right. So back in napkin math, you're going to get about 50% of raw. 50%. If you're only doing RAID 1, then you are going to get usable capacity at 50% of the raw storage. And if you're doing RAID 5 or RAID 6, back in napkin math, you're getting 65 to 70% of the raw storage as usable. So, obviously mileage varies, but yeah. So out of the gate, what will almost all the time happen is the customer is going to deploy a 3-node cluster, because the beauty of AVS and Azure is that you can scale on demand, right? So, okay, go with my 3 nodes. I consume what I'm going to consume, and now I need a 4th and a 5th, et cetera, et cetera. So out of the gate with vSAN, the configuration has to be, because this is just the way vSAN operates, is that it has to be FTTO1 and RAID 1. So as John talked about, you're in this mirroring configuration. So in other words, you're in the most non-optimal storage
expensive, right?
And expensive
right.
configuration you could possibly do on vSAN.
And that makes kittens very unhappy, apparently.
And yeah, if you don't want your cat looking like the cat in this picture, right, you are going to want to change your storage configuration as you grow, because if nothing is done, you are going to continue to grow this cluster with your 4th and your 5th and your 16th node crazy unoptimally, right? So what you're going to want to do is you're going to want to work with this customer to try to understand what of these configurations do you want once you get to that 4th, 5th, 6th node, whatever, right? And so generally speaking, what we see customers land on is they're doing a failure to tolerate of 1 or 2, and then of course doing RAID 5, right? Erasure coding. So and they are, just so you're aware, and everybody who's watching this is aware, is that your fails to tolerate are one thing. How many hosts do you want to be able to fail in a cluster and not lose data, or potentially lose data? And then the RAID level is something completely different, right? Do you want erasure coding or not? So if you do this pre-planning, your cat will be happy. And then right. As the cluster expands, your storage will be optimal.
So the tip is, when you make your cluster bigger, get off of RAID 1 if you're cool with going RAID 5 and calculating parity, because you're going to reduce your cost per terabyte.
That's right.
In aggregate across the cluster. So that's the important tip, everybody, and it makes kittens happy.
And so what you have to do operationally is that there's 2 things. You can change your default storage policy, which is highly recommended, to change that storage policy to whatever RAID and FTT level you want, and you can do that through the run commands in your AVS Private Cloud Azure portal screen. You would go to the run commands, you would select the set cluster default storage policy, and then you'll go ahead and pick that storage policy. So what you're doing by changing that default policy is, anytime a VM is moved onto vSAN, or you create a VM on vSAN, it will default to that storage policy.
Right. So defaulting to, say, to thin provision instead of thick, for example. Right.
Exactly. So now that storage policy is is applied on a virtual machine by virtual machine basis. So when you create a VM, that default storage policy is applied, but you may be in situations where you want to tweak that storage policy on a VM by VM level. Maybe you got some development systems that don't need FTT3 or whatever. So you can go disk by disk of that VM and tweak the policy as needed. And really why I'm bringing this up is not only for those purposes, but what you're going to have to do then is go back to those virtual machines that existed on that vSAN data store when it was a 3-node cluster and go and reconfigure those storage policies for those virtual machines. Because even though you change the default storage policy, it's not retroactive. It only
for new
applies
stuff
to things moving forward.
Gotcha. Okay. Good tip. So I can go back once I add all my nodes and turn everything to RAID 5 or RAID 6 if I'm going to be tolerant of calculating all the parity. Like the performance hit of writes will be higher, but it's locally attached disk. It's going to be very low latency. So who cares?
Exactly.
Right?
Exactly.
And so one of the things though and so once you've tweaked all that out, what we've run into is the need to shrink some of these VMs down. And like we said, Azure or file servers end up being one of those workloads where you got a lot of old data that you don't need to keep on high performance disk. And some of our VMware partners aren't as aware of all the cool stuff in Azure that we've got. And one of the things that we found to be super useful for file servers going to AVS is something called Azure File Sync. And what Azure File Sync is an agent you can run on a Windows-based file server that will synchronize files up to an Azure file share. So, if we've got a 3-node cluster and it costs 20 grand a month and we only get 20 usable terabytes out of it, the back of the envelope math is it's costing us $1,000 a terabyte for AVS storage, which sounds high, but you bought AVS for something else. Azure Files is $61 a terabyte a month in Azure. So if you can move data up to it, it makes a lot of sense. So you take a Windows file server, you load the agent in it, you can have the files, once they're synchronized up, appear in a different VM. So this makes it really useful for these cloud hybrid scenarios because I can present file servers in multiple locations, and I'll show you what that looks like in a minute. And then I can tier them. So once it's synchronized to the Azure file share, I can enable cloud tiering, and then on the VM themselves, I can just present the hierarchy. The NTFS data is going to live there, but the data in the files is going to be cached in Azure. And if we're running an AVS, we're in Azure. We're right next to our data store. So it's super fast to rehydrate files when people request them. So this tiering makes a lot of sense. Plus, then you can take advantage of cloud backup. I'm reducing further workloads that I would need to put in AVS. And I get near instantaneous disaster recovery for the VMs I'm running on AVS. In the event of a catastrophic failure, I could provision up a new VM, load up the Azure File Sync agent, and synchronize the file services dial tone to that file server and give back the services that people need. It's good for CryptoLocker defense as well. So it's a really cool tool. I said it on the top of the slide. It's magic wrapped in chocolate, but it isn't. Maybe it isn't, but it's pretty cool. And what it lets you migrate are shares, share permissions, and file system ACLs for domain joined Windows VMs. All while, if you want, you can reduce the storage cost, right? The number one use case is doing some things that OneDrive can't easily do. So in an Office 365 migration, you might move people's home drives to OneDrive and synchronize those up. But departmental shares, organizations have an investment in ACLs, and it's not user-specific data, it's departmental-specific data, and it's really hard to move that to SharePoint. I had one customer that called this Azure File Sync technology OneDrive for servers, right? But the key thing here is it's going to reduce the storage requirements and costs on our AVS cluster when we target file servers with stale data. I'm going to show you real quick how this manifests itself in my Azure environment. I'm just going to pop into a file server VM so you get the point. This file server, if we look at the F drive where the file shares live, it's only got a 32 gig volume. It's tiny, right? But if we look at the shares folder rather than the volume, and we look at properties, it's got way more than 32 gigs. It's actually presenting 1.5 terabytes of data. So it's got a 1.5 terabytes of data in a 32 gig bag, as it were. So I've smushified a lot of data in here. And if I look at the individual files, like here's a video of a classical symphony that I've got here, it's not using any data on disk, but when I double click on it, it instantaneously rehydrates the file at the speed of my link to Azure. And we can see the video is going ahead and playing. I can index it. It's bringing the file back in real time with the user, me, none the wiser. So we can do that. And I just hit properties. We'll see now that it's pulled 50 megs of data back to my host, which are cached on that 32 gig volume. I'll just show you in Azure real quick what the secret sauce is. And it's really about having an Azure file share that you create. Again, in Azure Commercial, it's about $61 terabyte a month for the transaction optimized level. And that's the cloud endpoint. That's where I'm synchronizing all my data on a per volume basis. And then I've got multiple hosts all synchronizing or having access to that file share, including the one we just saw, which has a 32 gig volume here with 1.2 terabytes of data accessible to it. And I've enabled cloud tiering, and that allows me to rehydrate those files as I go, setting a date policy for what constitutes a hot file. So any file that's been accessed in the last 30 days, I'm going to keep a local cache of. And I can also set a volume free space policy. So I can always maintain kind of interesting amount of write capacity on my VMs. So that's kind of the quick and dirty of Azure File Sync, just to give you a taste of one strategy that we like to employ to smushify down those file servers. So to summarize, if I've got a vSAN and it's cranky because I want to move my VMs up to Azure, I can go ahead on those file servers, run the Azure File Sync agent, make the storage capacity less, put myself in a happier storage position, and ultimately reduce my storage requirements in AVS. Trevor and I collaborated last year on a couple of blog posts, and we'll share these slides with you on how to actually run through this with Hyper-V or VMware-based VMs. The secret sauce here is once you've moved the data up to Azure and enabled tiering so it doesn't need to be local, is running a PowerShell command to tier the data, get it off the file server itself, and then zeroing out the data. So we used a Mark Russinovich command called sdelete that allowed us to zero out the disk so that we could essentially dedupe it, or either dedupe it if our storage supported it, or compress the VMDK using some other commands, if that makes sense. And it's a pretty straightforward process, don't you think, Trevor?
Yeah, and what from an AVS customer perspective, why they like this, and folks may have picked up on this a few slides ago, is you don't have to change operationally how you're doing anything, right? Because a lot of times people are coming to AVS because look, they just need to rapidly get to Azure, or get out of their data center, or whatever reason they have, they don't want to refactor every application and slowly move workloads. And so what this allows them to do is take advantage of these Azure services that are wrapped around your AVS private cloud with extremely minimal impact from a learning curve and operational perspective.
And I'd call it's kind of a training wheels workload too. So for these organizations that don't know a lot about Azure, loading up Azure File Sync and setting it up takes no more than an hour if you know what you're doing, and you can slow roll into it. And I'll just mention another file server workload that we've seen that's worth shrinking is DFSR replicas. So people have deployed DFS, which is a distributed file system in Windows where they have replicas of data scattered through their organization. And it doesn't make sense to move those up to Azure because they're all giant behemoth copies of the same files. So instead, we would recommend you load that file sync agent on one of them, create new VMs in AVS, and just synchronize little bits of data to those VMs in AVS, and then have them participate in the DFS namespace. And we've got more detailed slides on how to do this that we can share that'll be hidden in the deck. But then ultimately, they can just retire those workloads. And again, it doesn't require a lot of expertise or changing what you're doing. It's still using DFS, and you're just going to modern replication, and you can still host it all in AVS.
Yep.
There are some other cool shrinkage tools that we've run across for file services. One I really like is one called Tiger Bridge from Tiger Technologies. It's very similar to File Sync, but it'll tier to blob, so it actually ends up being lower cost. For Linux boxes and everything I've talked about with File Sync, those are Windows only for file servers. But there's a Linux driver that you can go download and install in Linux that allow you to mount Azure Blob storage in Linux VMs as a file system. So you can do some really cool stuff to shrink some Linux boxes down by using blob views. And again, you're connected to Azure with a 10 gig link from AVS, it's going to run like a gazelle. So go ahead and try to use it, but you can save a lot of cost, particularly for certain data ingestion workloads. There are a bunch of file archiving solutions out there that'll also help, things like HubStore, Moonwalk, Archive 360, and a bajillion more that'll do similar things, but they're worth investigating as well. The whales we didn't really talk about. Oh, go ahead, Trevor.
Yeah, and so as John was saying, as the whales we didn't talk about are databases. So we've addressed the file servers that you tend to run into, but the other huge storage consumption we tend to see are SQL Server. As I was just mentioning, right? People want to come to AVS. Companies want to come to AVS, and one of the big value props is you don't have to change anything, right? But there are times where it may make sense to cherry pick things that you're actually going to, change. And what I mean by that is that you need to work with the customer to look at, okay, moving, like right now I'm working with a customer who they have a single SQL server that they would need 3 or 4 hosts just to support, right? So it doesn't make sense for them to pay for that amount of hosts for one SQL server, essentially, and weighed against just moving that one SQL server to an Azure IaaS VM or some other SQL service running inside of Azure.
Like a SQL managed instance or Azure SQL or
Right.
Cosmos DB. The value is taking all those ancillary reporting servers and application servers and shifting them to AVS with no change, right?
Right.
Maybe you change a SQL connection string, but you've not interrupted or messed with your operation. You've just let the database guys make a quick change, move the data somewhere.
Right. And so it's a business conversation you have to have with the customer to say, okay, well, the I don't want to change anything. Is that worth this amount of money? And if it's not, then why don't you change this one thing and it can save you this amount of money, right? So there's not a right or a wrong answer, but it's something that, literally yesterday I had a conversation with a customer and kind of put that at their feet and said, you kind of got to make a decision here. Right. And it not one decision is not right or wrong, but there's a cost to each of them, and you need to weigh that cost.
Cool. And I guess the other big whale besides file services and databases is really backup, right?
Yeah, of course, right. So right now, what you're probably experiencing is that you have some backup hosts that are running on your vSphere cluster, and you're using some type of local disk, i.e. something on your SAN or whatever to store these backups, et cetera, et cetera. So what I typically advise customers of is, operationally, nothing changes when you're coming from AVS, but you really do need to change the way you do backups, because those VMs that are running inside an AVS private cloud, most certainly, unless they're development workloads or throwaway workloads, certainly do need to be backed up, just as they do on-prem. So you're going to want to back up to solutions that sit inside of Azure and leverage Azure disks to house those blocks.
Right, but don't crowd your AVS storage with your backup servers. Essentially, that's what you're saying.
Yeah,
it doesn't make sense, right?
It makes no sense.
Not just that, but you're potentially putting yourself at risk because you've got the same fault domain for your production workloads and your backups.
Yeah,
right?
Exactly. So by using Azure native backup services like Microsoft Azure Backup Server, you can then take those backups, move them off to Azure native disks, and then replicate those disks to wherever you want to replicate them, to anywhere in the Azure fabric globally. Azure Backup does integrate quite well, and we won't go into the gory details of it, but Azure Backup has a nice integration with vSphere, and you can do backup to Azure Disk, and then do restores at an enterprise class level like customers expect. I want to be able to pull a file. I want to be able to restore an entire VM, things like this. So you really want to work with your customer on re-architecting their backup solution for a cloud platform.
Yeah, well, I mean, Azure Backups, Microsoft Azure Backup and Azure Backup Server, it's the Azure Backup Server is based on DPM, right, which came out in 2007. Wasn't necessarily always the most VMware friendly backup solution or non-Windows backup solution available. It does a lot of neat stuff, but it doesn't do a great job in all scenarios. Like you can't support VMs with pass-through disk is kind of a problem, right? It doesn't connect or protect VMware vApps. I don't even know what those are, but it's on the slide. and it also has some issues around retention periods. The important thing is Azure Backup Server is an option. There are, of course, other options from third parties that your customer may already be using. I mean, every VMware customer I run into has either got Commvault or Veeam that I usually typically run into. And if they've got it, bring it into Azure. Just don't put the backup server instance in AVS. Put it in Azure. Mm-hmm. So you're not burdening your storage infrastructure with those pieces. What do you have a take, Trevor, on using something like Azure Site Recovery with AVS? Is that a thing?
Yeah, I mean that'll come in when customers want a DR solution, right? So if they have AVS and they want to DR those workloads that are running on AVS, you certainly can use Azure Site Recovery. I mean, you'll typically want to pair that with some solutions that replicate your kind of tier 0 workloads directly to another AVS private cloud. But if you're
like SRM or something,
yeah, like SRM. So you may want to SRM your tier 0 workloads from a recovery, time objective to another AVS private cloud, like a 3-node, 4-node cluster somewhere else, and then use Azure Site Recovery for those other workloads that have a recovery time objective of,
I brought it up, but I think your point earlier of like workloads or customers who don't want to change stuff, they're not as amenable to Azure Site Recovery, right? Because that's a change, right? Oh, so wait, I'm going to move all this stuff to VMware in your cloud, and now I'm going to replicate it to Azure for DR. That's usually a non-starter for a lot of those folks, right?
Yeah. So there's a lot of these types of backup options which they use for disaster recovery as well, right? And typically from a backup perspective, what I'll advise the customer of is like, hey, what do you use on-prem? Oh, I use Rubrik. Cool. Go talk to Rubrik. Tell them you're going to have an AVS private cloud, and have them explain to you what solution they have inside of Azure that you can back up your VMs from AVS.
Cool. So now we've kind of talked about some ways to reduce your storage utilization. Inevitably, you're going to run into issues where, from a customer perspective, they're going to want to add storage. They've done all the heavy lifting associated with shrinking things down, moving some of these workloads off, but they really just need some more storage, right? And there are two options that are in preview. One, using Azure NetApp Files, which is native Flash NetApp filers in Azure to connect to NFS volumes that you create there, or using something called disk pools, which provides iSCSI access to your AVS clusters. Both of these are in preview right now. We'll chat a little bit about it. So they're not available in every region. They're not even available in the region where Trevor has his test environment. So we couldn't fire these up in our test environment. We still played with the technology because we've done a lot with ANF. So we're just going to overview these two for you. We expect that both ANF and the iSCSI disk pools piece are going to be available within the coming months. One's in private preview, one's in public preview right now. The only way you can really provision either of them up is to use the command lines in Azure, the Azure CLI or PowerShell, because unlike a traditional VMware setup, as Trevor was explaining to me, I can't just pop into the storage config in my VMware environment and connect to the ANF environment, because I don't have rights to go into the storage management piece and provision up a new remote data store. I've got to do it from the Azure side because of the way we do RBAC. I think that's a reasonable summary of all that, Trevor, isn't it?
Yeah, exactly. On-prem, you're used to going into vCenter and mounting data stores, but here inside of because AVS is a managed service, right? We try to abstract that away and expose that inside of native Azure portal.
Yep. So there's a link here that will take you to the kind of preview documentation on how to set it up. Really, all you've got to do is set up an Azure NetApp file storage account in Azure, which is like a regular storage account, but it's for Azure NetApp files. Create a storage pool, and you have to provision a minimum of 4 terabytes of storage on the ANF storage account, and then create a volume. You can make it a standard ANF volume, a premium, or an ultra one. It's all running on the same flash storage. It's just going to provision your performance and limit your performance based on QoS. For most of the applications that I see, for this in particular, because you're going to be introducing a little bit of latency going through a router, you're probably fine with standard, right? And it's gonna cost about $150 a terabyte a month, capacity wise. Again, less than what you've got on the ANF or the AVS cluster from a per terabyte perspective, but not an unreasonable amount for high performing flash storage that you're going to be able to NFS mount.
Right. So just to add to that, as we're recording this presentation, right, as you mentioned, we're in preview right now, and if there are any customers that you, the partners, are working with that would like to participate in a private preview, just reach out to me directly, and we can help assist with that.
Cool. Right. And I guess the other thing is some of the documentation points to the fact that I can access ANF in my VMs, right? So I can go to an NFS share or an SMB share and get to it through the router. The thing that's in preview is really having the AVS nodes access the NFS shares as a store, right? Which is really the valuable piece. So I can do a lot of cool VMDKification right there, right?
Right. Yeah. From a VM level, you can do anything you do today, right? We run into customers who mount iSCSI volumes, from their VM directly, and they want to still do that in AVS, and they do that, and they'll do it back to a native Azure iSCSI share, things like that. So yeah, so from a VM level, you can do it all, but it's at the host level where these two things are in preview.
So again, this is Azure NetApp files with mounting an NFS volume for your store. The alternative to that is something called Azure Disk Pools, which is also in preview. And what this actually provisions up when you create a disk pool is it creates a redundant set of virtual machines based on your performance requirements that are running Linux that you attach Azure native disks to, and then present out from the VMs, which are iSCSI targets, out to the data store. And again, you're using Azure command line options to provision that up. There's probably going to be a little higher latency with this technology based on my testing, and also because now you're not going directly to the NetApp storage like you were with the ANF NFS mounts. You're going from the Azure disk, which is abstracted blob storage that then is being presented via iSCSI from a Linux VM. So there's extra hops that are introduced with this technology, and then you're going to mount it as iSCSI LUNs in your Azure VMware Solutions Cloud, if that makes sense. Did I say that right?
At the end, what you'll see, regardless of which solution you would pick for a data store, is that from a customer perspective, right, they're going to have a data store. Now, just like they would on-prem, right? That data store will be presented to the cluster. Now the question is it backed by Azure Disks, Azure Disk Pools, or is it backed by ANF?
Right. And so the architecture is going to be pretty similar to what we would have seen for anything else that's hosted in Azure. Essentially, either the ANF cluster mounts, which are going to be NFS, or these iSCSI disk pool mounts are going to be in your Azure subscription on an Azure VNet that you're going to want to have in the same Azure region as your AVS setup. And you are going to go through the dedicated edge router to get to it, right? So that's where the potential latency is going to be coming in, is because it's going to be bouncing through that router. Now, it's a 10 gig connection. It's very close to your storage. It's not horrible, but just mentioning that it's not going to be as low latency and performant as the locally attached disk on your AVS cluster, right?
But for many workloads, right, what we see is that it can support that, right? Not your, we're not saying go put your ridiculously highly transactional SQL server over there, right? But
and it's because of the router, because we do have
right.
people putting SQL Server and Oracle workloads on ANF, right?
Oh, yeah, absolutely, right. But it's because of the way AVS is architected, right? Yeah, your most extreme performant workload, demand, put it on the vSAN cluster. But in reality, the bulk of all workloads are not ridiculously high demanding in terms of storage requirements and whatever. So it's about looking at your environment holistically and deciding what's the best place to put these things.
Right. If you got a database, yeah, leave that run. Let the database in the log store live on AVS, but maybe you dump your logs for log shipping purposes over to ANF.
Mm-hmm.
Right.
Exactly.
So because you can build a big archive. This slide, we just go into a couple other points. One is I'll make the disk pools piece. You can only use SSD, standard, premium, or ultra disk, and it changes the cost a little bit. And I'll just mention that again, the architecture is going to be from a costing perspective. It's going to be the cost of the disks that you provision. And what I did down here was I priced out in US East 4 terabytes of capacity for ANF standard, premium, and ultra, and then also a 4 terabyte Azure disk plus the VM compute that's associated with it at 3 different performance levels using Azure Disk, right? And what you'll see is ANF ends up being about the same for the capacity from a dollars per terabyte perspective. So for ANF standard, it's about $150 a terabyte. Again, much less than the ANF storage. But when I get into the disk pools piece, my storage is going to vary based on the type of disk that I use, and then the size of the VMs that are providing those iSCSI target services mounting those VMs. So in this case, I went with the cheap ones, which provisioned up 2 D series VMs, which was $560 on top of the storage cost that I needed to add. Estimating the ultra storage cost, much harder because you pay for a certain amount of IOPS and throughput as you fire it all up. Plus those iSCSI VMs to support kind of those higher IOPS, you're going to want a better iSCSI target to make it all happen. The point being is they're both going to be interesting options. I think ANF is going to ultimately be lower latency when it goes into production than the disk pools piece. And it's probably going to be easier to manage because when you need more capacity, you're just going to spin up, you're going to make your volume bigger, right? You're not going to have to go in, create a new disk, resize your disk, or add another disk as an iSCSI target. It's going to be inherently mounted on the store, as far as I can imagine, right?
Yep.
So ANF is there, disk pools is there and available to you. You can't use other iSCSI options like SoftNAS because again, you can't get to the iSCSI initiator in the vSAN storage side of it or the AVS storage side of it. You got to go through the command line or the portal to do it. And these are the 2 options that are going to be available to you. So in summary, I'll start talking a little slower. It's important to understand what your core storage requirements are going to be, and understanding what some of those big VM workloads that maybe you can make some adjustments to might be, so you're not going to have storage bound nodes. shrinking some of these VMs and the storage requirements is going to be a big help to balancing out the value of AVS and the workloads for you. And also, there are options for attaching more storage that are in preview right now, and they're gonna make things a lot simpler for you as you go forward, I think. All right, Trev, anything else you wanna layer on? Any parting thoughts, you think?
No, I think that that kind of covers it, right? And what I would just say is that do spend the time with the customer to try to help find some easy ways to lessen the storage need on the AVS private cloud, right? If you see that is driving the growth, because at the end it's gonna be a better solution for the customer.
Great. Well, thanks everybody for your time. Hope you have a great holiday season, and look forward to working with you. If you have any questions, again, you could reach out to Trevor and I here at Microsoft, and we'll see if we can help you out.
Thanks, John.
Everybody.